Welcome back, everyone. This is Wes Baxter. I'm a math professor at Nashville State Community College, and we are producing these videos to help you guys understand how to solve some of these problems, especially on the calculator. This particular video is looking at when you have problems where interest is being compounded at certain intervals of time. So that means that the interest is not being compounded continuously. It's not. So you have compounding of interest at certain intervals of time. We're going to take a look at two different graphical approaches in this video, and I also showed you these approaches in a previous video as well, so you might go back and review that. But let's take a look at what we have here. The purpose of this video is to help you understand how to solve interest-related problems that do not involve continuous compounding. And again, we're looking at two graphical approaches. Here's our sample problem that we're working with. Jamaica invests $10,000 in an account that pays 4.5% interest that is compounded monthly. Notice it doesn't say it's compounded continuously, it's compounded monthly. So we have these intervals of time when it's compounded. The question is, how long will it take for the account balance to reach $25,000? Now remember, when you have interest being compounded at certain intervals of time, such as daily, monthly, quarterly, semi-annually, annually, etc., you are to use the function that we have on the screen. So you want to be very familiar with this particular equation or function. It's a of t equals p times 1 plus r divided by n, and that quantity raised to the n times t power. Now we know what all these things are because we talked about this in the previous video. The only thing really new is the n, and the n represents the number of times that you're compounding the interest per year. All right, so in our particular example, because the interest is compounded monthly, the n is going to be 12 because there's 12 months in 1 year. Okay, so both of those n's are going to be 12. All right, so here's our sample problem again. Now let's see how this works. So let's take a look at the two different methods. Now we have our zero method, and once again, you've seen this before, but what you can do is you can get a zero on one side of the equation, and then once you have the zero, you can graph the function that you get on the other side of the equation, and then we can find the zero of the function using the calculator, okay? And then that zero is the solution. So, all right, so let's take a look. All right, so let me switch my screens. Give me just a moment to do so. Okay, so first, let me write down our formula that we're allowed to use, okay, because we're compounding at certain intervals of time. So you always want to use this particular equation. We have a of t equals p times 1 plus r over n, and that's raised to the n times t power. I'm going to plug in the various things that we know. We know the future value of the account balance. That's going to be the $25,000. So that's the a of t right here. The P, or the initial investment, is $10,000. That's the P. And that is being multiplied by 1 plus. Now, the interest rate is 4.5%, but you change the percentage to a decimal. So you move that decimal back to the left 2 spaces, and that's going to give us the 0.045 that we have. And again, the n in this case is 12. So wherever you have an n, put 12. And we don't know the time. That's what we're trying to find in this example. So just leave that as t. Okay. In the previous video, we already did this work inside the parentheses. And we found that to be 1.00375. All right, so let me just write that in. So we have 10,000 times 1.00375, and that's raised to the 12 times t power. Now for this method, what you want to do is you want to get a 0 on that one side of the equation. So I want to get rid of the 25,000 on that left side. So I'm just going to subtract 25,000. Just subtract 25,000 on both sides. And that will give me my 0. And then this is what I have on the right. Minus 25,000. Okay, so what you have here is going to be your function. And notice, we're trying to figure out what value for the t here will cause all of this to equal 0. All right, so to do that graphically, it's quite simple, actually, once you get used to it. So we can just, we're going to graph this function that we have right here, and we're going to find the value for t that causes that to equal 0. So we're going to find the 0 then. Okay, so let's go to our calculator. I'm going to actually just graph this function right here and then find its 0. So let me switch screens again. Right, there we go. Okay. All right, so to graph the function, I'm going to press y equals, and I need to clear out what I've got in there. Okay, so just clear those out. All right, so go to y1, and I'm just going to type in what I've got. So I've got 10,000. I do want to hit times, and then my base is 1.00375. And that's going to be raised. So I want to hit this caret button to raise that to the power of 12 times. I want to hit times t. I'm just going to let it be x. I'll just hit this button. That's the variable button. All right. And then to exit out of the exponent, I've got to press the right arrow key. And that brings me back down, and I can just put in now minus 25,000. All right, so that was the function that I had after getting that 0 on the one side of the equation. Now I need to graph this, but now before graphing anything, I want to think about the window. If the window is not provided to me, I have to think a little bit about how to get a proper window so that I can see what's going on. If I can't see the 0, I can't find the 0. So to think about the window, always do this, guys. Hit second table, and in this particular case, for this method, I'm wanting to find where the 0 is, and that means where the y value is equal to 0. And I can see by looking at this that it is going to be right in here. Do y'all see that? So somewhere between x equals 20 and x equals 21, we do have this value of 0 here, because these values above here are negative, and then these values down here are positive. Okay. So what you want to do then is you want to set up your window properly. Think about the x values that you need to see. All right, so the number that we're trying to see is something between 20 and 21 here, because that's where the 0 happens. All right, so just create a range of values around that particular value, just to make sure that you can see it. All right, like you don't want your window just to be right there at it. Like you would not want to put the window as being between 20 and 21, probably, because you might not be able to see it well. So just sort of expand your values out away from this value and just create a range wide enough to make sure that you can see what's going on. All right. So what I'll do is I'm going to leave my X minimum and X maximum like they are, because that's going to give me like a nice wide view so that I can see that zero in the middle here. The zero, the value of 20 or 21 is kind of right in the middle of this range from 15 to 27. Hopefully that makes sense. And then I'm going to go back to my table of values. So I hit second table, and I'm going to think about my Y values just for a second. Now the Y values, they change very quickly, as you notice. So very quickly we go from 0 to 5,000, you know, both to the positive direction and also the negative direction. The negative numbers here are increasing very rapidly as you go up this way. So then to get a nice range then around the 0, just to make sure I can see it, you just want to account for this quick change in the Y's. All right, so when I go to set up my Y minimum, I'm going to let that be negative, we'll say negative 5,000, you know, because those negative numbers increase quite quickly. And then I'm going to make the Y maximum be positive 5,000. That should be enough of a range where I can see the 0 that's in the middle of these values. I hope that makes sense, guys, because being able to find a proper window is so powerful. Once you understand that, you can use your calculator for some. So try to make sure that makes sense. If it doesn't, ask your instructor for more help with that. Once you have the window set, you can graph and see, you know, because we have a nice window set up, we can easily see the 0 that's happening right here. There it is. And we just need to find the 0. All right. And then to find the 0, we can do second trace. You want to select 0, hit enter. And this is where we do the left and right bound. All right. So to do a left bound, just move your cursor to the left by hitting the left arrow button and move the cursor to the left of the 0 that you're trying to find, and put some good distance in there. All right. Once you have a good left bound, press enter. And again, it puts a flag right above where you set that left bound. Now to get a right bound, just press the right arrow key to move it along the graph to the right. All right. And so see that point right there it's a good point that's to the right of the point that we're trying to find. Put some good distance in there. You know, don't try to set the right bound super close to the 0 that we're trying to find, because the calculator may not do it correctly then. I always say leave plenty of distance between your cursor and the point that you're trying to find. And hit enter. And that puts that flag up there. Just verify that your 0 is actually between the two flags. And yes, it is in that interval. Okay. And so you're ready to hit enter again. And it gives you the solution to the equation, 20.40. Okay, so that's the method, guys. So practice with this. You can solve lots of different types of equations this way, okay? Let's take a look at the other type of graphical approach. Let me return back to my presentation here. The other approach that we want to look at is the intersect method. And again, I showed you this in a previous video, so we're just going to practice with this again. Basically, what you do is once you have your equation written out using the formula that you can use, whatever is on the left side of the equation, we're going to label that as y1. And whatever is on the right side, we label that as y2. And we treat those as two different functions. We graph the two functions, we find the intersection of them. And by finding the intersection, that allows us to find the solution to the equation. It's really cool. So let me demonstrate. All right. So for this method, now there's no need to get a 0 on the one side. You could just simply, as soon as you have your equation written using the formula, you can just make use of that. Okay, so there was our equation. And then, we could simplify it a little bit so that I don't have to punch in all this on my calculator. So let me simplify what's inside the parentheses there. We know that that's 1.00375 to the 12t power. Okay, so there's my equation. And so all you do is you just let whatever's on the left side be y1, let whatever's on the right be y2. Treat those as functions, and we're just going to find the intersection of them. So let me demonstrate on my calculator. And you guys, make sure you practice with these. All right, so let me clear out what's in there. All right, so y1, again, is just the left side. So, you would just press y equals to get to your y equals screen, and then just type in y1 equals that left side, whatever it is, 25,000 in this example. Go to y2, type in just whatever is there. Now you do have to hit times right here, so be careful with that. So you do have to tell the calculator when you're doing an operation, such as multiplying. So it's 10,000 times 1.00375, and that base is raised to the power of 12 times t. And I'm just going to have x showing on the screen because that's what that button puts on there. Okay, so I've got both sides put in. I've got y1 and y2, and I need to find the intersection of these now. All right, so now before I go to graph it to get the intersection, I've got to think about my window. All right, and again, to think about the window, go to your table of values, do second table, and you have to kind of think a little bit here. Now, with this method, I'm trying to find the intersection of these two graphs, y1 and y2. In other words, I'm trying to find where they are the same value. And as you look at this, it looks like they do have the same value of 25,000 at some point right in here between where x equals 20 and x equals 21. So I make note of the y values. Now the y values, again, they're changing very quickly. So as you go away from the value of 25,000, as you look up at these values, the values are decreasing rapidly up this way, and they're increasing rapidly down this way. So to make sure I get a good window so that I can see where that point is, I want to make sure that I set my y values correctly. So I think what I'll do is I'm going to let my y minimum be, some value less than 25,000, but less enough so that I can see what's going on. So because those values are changing very quickly, I'm going to go ahead and just say, I'll say 20,000. And then for the y max, I'll let that be 30,000. Okay. And just think, so the 25,000, that we are trying to see, 25,000, of course, is in between these two values. And we have enough of a spread around the value 25,000 just to make sure we can see what's going on. Okay. If you have the window mastered, that is great, guys. So keep practicing with that. Now, once I have a good window set, then I just hit graph and I can easily see my intersection. So here's the intersection of the two functions right in here. And of course, to find the intersection, I just do second, trace, and I go to intersect, hit enter. And we saw this on the previous recording. So it says first curve. Now curve just refers to a function. So the calculator is just needing you to give it a point that is on the first function. So what I would do is I would just place my cursor pretty close to where the intersection is here, and then just press enter. And it's going to capture that first function. And then I'm going to hit my left and right arrow keys now just to see which of those functions my cursor is on. All right, so it looks like it's locked into this other graph here. And that's the one that I want it to be on, because that's going to help it pick up that second function. All right, so just press enter. As long as it's on that second function, just press enter to give it a point on that function. And once you have given the calculator a point on both functions, it's ready to find the intersection. So just press enter and look at that, guys. There's our solution again, 20.40. So that's what we're looking for. All right, awesome. So I really hope that this is helping you guys to see how you can use your graphing calculator to find these solutions. Please practice with these, and you can practice with this using all types of different equations. So practice with other problems, okay? All right, I wish you luck, and I'll see you in the next video.